Today is we're gonna be working with section 10.2 rational exponents, and there's several things that you guys need to remember from radical expressions because it's been a while since we saw them last semester. So remember this house would be the radical if you guys remember. So this thing, whatever's inside, it can be multiple things. It can be a binomial, it can be just a number. Whatever's inside is called the radicand, and this one would be the index, or like the root that you're taking from this, like the cube root, the fourth root. That would be the index at the end. If you don't see a number here, usually there's no number. That would be square root. But if it's higher than a square than a 2, then you would start seeing numbers here, like 3, 4, and 5, and so on. Okay, this is just a review. You will also need to remember the rules of exponents, and I do have a little warm-up on them. I'll take a picture of these later and put them on the assignment as notes. Okay, there's two definitions for this one. This is the first definition. So that's a rational. I should have put that. This is the radical form. Radical. This would be the radical. This would be the radical form. This is our rational form. Rational exponents. Rational exponents. So we're talking about the exponents. So this thing. The exponent would be a rational number in a fraction. This would be the radical. So they're saying when something like a would be is raised to the 1 over n being a rational, you can actually rewrite this as a radical. The bottom number here in the exponent, in this fraction, in the exponent, the bottom number would be the index, or the root. The base of the rational exponent number, the base, the a, would be the radicand, the number inside the house, inside the radical. And that's all you're saying, and it's better with numbers, but that's the general form. The other one, this is from rules of exponents. When something is raised to the negative rational number, so negative m over n. So like this, when something's raised to a negative m over n, the equivalent of that, because we don't want negatives, would be 1. Remember, guys, that 1 over this thing, a to the m over n, without the negative. You do this to get rid of that negative. That's the whole purpose of this, because we don't want negatives as exponents. Okay, so going into today's examples, this one is saying use radical notation to write the following. So they're giving you rational exponents, rational fractions, and they want you to write it in radical form, the one with the house. So this one would be, so you would do a little house. So remember the base, which is the 4, would go inside. The 2 goes outside. Usually when it's a 2, that would be a square root. They don't put it. I'm just gonna put it for you guys, but usually they don't have the 2. They have a 3 and more. So the 2 becomes that index, and the base would become that. The 1 has part in that radical, but since it's a 1, we don't really need it. But if this was higher, then it would influence what we have here with the 4. It could be outside, but I'll show you later, because none of these ones have that. So B, again, you would write the house, and then, well, here we forgot to simplify all the way. So the square root of 4 would just be 2. Forgot that here. Okay, here, remember, so the number would be inside. The 3 would be the index outside. and then this is just a 1, so we don't need to put it here. So this is asking cube root of 64. So you're trying to find a number where you multiply it 3 times the same number. That would give you this. And I know that's number 4. So this is a review from last semester. So when they say cube root of 64, they're actually asking you to find a number where if you multiply that number 3 times, it would give you this. 4, if you multiply 4 times 4 times 4, gives you 64. That's why the cube root of that number would be 4. Cube 3 times. 3 times the 4 gives you that number inside, so the cube root would be 4. Same here. 2 times 2 gives you 4. Square root now meaning 2 numbers, so twice. I mean, if you multiply the same number twice, it gives you that number inside, so the square root of that number would be 2. Okay, now let's do it with letters. It's just the same thing. You would write the radical, you would put the base inside, and then you would put this as the index. So the number below this fraction, the denominator of the exponent, would be the index here. And that's it for that one. We can simplify further. For this one, it would be again the radical. You have the 0 inside, and this 6 would be the number here, the index, so the 6th root of 0. So just a number where you multiply it 6 times, that will give you 0. Well, you guys know that would be just 0, because if 0 times 0 times 0 6 times, doesn't matter how many times they ask you, it's always going to be 0, right? 1 2 3 4 5 6. Okay, this one, that one has a negative, but if you guys notice, this is where you have to be careful. That negative doesn't really, it's not being affected by that exponent because there's no parentheses around it. So there's no parentheses around it, so that means that exponent only applies to that 9. So you would put the house, the radical, that negative would be outside, right? And then the 9, the base, would be inside the radical. So remember, that negative is just outside. So forget about the negative, just put it outside. Okay, you're done with that one. Think about the 9 raised to the 1/2. That would be the radical, because they want you to convert to radical. And then the 2, which you won't have it when the index is a 2, they don't put it for you. They just leave it blank. But I'm gonna put in it for this so that you guys know what I'm talking about. So what's the square root of 9? So you know it's 3, and then you have the negative outside. It's negative. So that would be the answer for this one. That would be the answer, and that one's just the answer. Now with this one, again, you would put the radical. Now if you notice, this is in parentheses, so the whole thing raised to the 1/4. So the whole thing is part of the radicand. So you would put this whole thing, because of the parentheses, inside here. And then this exponent goes outside. I'm going to put it with the green one. So 4, this is the index, the denominator of this exponent. Now, when you're simplifying, you have to find the 4th root of 81 and the 4th root of x to the 8. This is the part which is a review, but maybe you guys forgot. So find a number where you multiply 4 times, that would give you 81. That would be 3 times 3 times 3 times 3. If you multiply this number 4 times, it gives you 81. So the 4th root of 81 would be 3. Now find an x elevated to a power that would give you, that you multiply 4 times, that would give you this x to the 8. So, and that would be x squared times x squared times x squared times x squared. This is where you apply the rules of exponents. So what happens when you're multiplying this? This is a product. This is a product rule. So you're basically adding all the exponents. They have the same base, and you can add all of their exponents. 2 plus 2 plus 2 plus 2, that gives you x to the 8th. So what's the 4 root of x8? Is x squared. X squared. That would be the answer. Now there's another way when there's no parentheses, there's no negative numbers, everything. This is what you can do also for this one. You can always divide that exponent by the index, and that will tell you the cube root of that. So a divided by 4, so you know that's square, x squared. So that's another way to find the 4 root of that. So that's the answer. These are just, let me put a note here. This is just a note how to find those things. Okay, now this one, G. If you notice again, this is like this. The negative wasn't part of the 9. Here, everything was part of this exponent. Here, if you guys notice, a 5 is not being affected. It's not part of that exponent. That exponent only applies to that y. So that 5, we're just going to leave it outside like that. And then you're going to put the radical because that's what they want. So the base of this is the radicand here. That the denominator of that exponent would be the index here. And they want you to find the cube root of y, which you can't. It's not a perfect one, so this is the answer. So that would be the answer, the whole thing. Same here, I didn't square it, but that would be the answer for that one. Okay, let's move on. I don't know if I'm gonna get to all of them. So it's gonna take me a while. So example 2, use radical notation to write the following. So again, we're using radical notation, the same house, but now we have an exponent. So this is the example where you're gonna put the house, you're gonna put the base goes inside. I'm gonna start changing the color of that. So the base goes in the inside, and then that 2 we don't need it, but I'm gonna put it just in case. I'm gonna put it here, and then the 3. For this type of question, you're gonna have to be very smart where you put it. I'm gonna put it outside for this one because I know 3 cannot be divided by 2 from here, right? So I'm gonna put that. I'm put in parentheses, and I'm gonna put that 3. So now it has a meaning. So the 3 is the exponent outside. So now let's simplify the parentheses. So square root of 4 would be 2 raised to that 3 outside. We got rid of this by doing the square root of that, but we still have that to work with. And that 3 tells you how many times you're multiplying the base. So this is basically, I'm going to put it here, 2 times 2 times 2 gives you 8. I won't put that all the time, just wanted to show you for this example. So 2/3 is you're multiplying 3 times, that'll give you 8. So that would be the answer for that one. So for B, so again, that negative, you guys notice, it's not being affected by that exponent, that rational exponent, because it's outside. So I'm gonna put it outside, and then I'm gonna put the radical, and then the base is the radicand. The denominator of this rational exponent is the index, which is 4, and then here, this is where you put the parentheses because we have that 3. So that 3 here is the exponent over here outside. So now let's simplify the 4 root of 16. So you're trying to find a number where you multiply 4 times will give you 16, and I know that's 2. 2 times 2 times 2 times 2 gives you 16. 2 times 2, 4 times 2, 8 times 2, 16. So the 4 root of 16 would be, so remember you still have that negative, it would be 2 again raised to the third power. So 2 to the third power, you know it's 8, right? And you have that negative, so negative 8. And that's the answer for this one. Now this one, if you notice the difference here, now the negative, it's being affected by that rational exponent. It's part of this 27. So this negative, you can't put it outside. It's part of the radicand. So this negative 27 would be inside. And then that denominator in the rational exponent would be the index here. And then you put parentheses. And then you still have that number as the exponent here outside. So we're going to find the cube root of negative 27. So cube roots, odd roots do have negative numbers inside as the radicand. It's possible. So that means you're trying to find a number where you multiply 3 times will give you negative 27. And that would be negative 3. Negative 3 times negative 3 times negative 3 has to be 3 times. Negative 3 times negative 3 gives you positive 9. I'm going to put an extra step here. Times that negative 3 will give you negative 27. So this is the cube root of negative 27. So that means we got negative 3 for the inside. Parentheses, and we still have that 2 outside. So what's negative 3 squared? You're multiplying these twice. So you're multiplying 2 negatives. That becomes a positive. So negative 3 squared would become positive 9. That would be the answer for that one. So this one, it's a rational number here raised to a rational exponent. So a lot of rational stuff. So for this one, this whole thing would be part of the thing inside the radical. That so that's the radical. You have this inside 1/9. It would be just the same as like this one. Everything's inside. Everything in that parenthesis becomes the radicand. So everything in here becomes the radicand inside the radical. And then that too, remember they don't put it here, but I'm gonna put it for you guys. Is the index, the root, so square root, and then the parentheses because you have that exponent. That would be the one outside. Okay. So what's the square root of 1/9? So you can do it individually. You can do the square root of 1. You know that's just 1. The square root of 9. So a number that you multiply twice, that would give you 9. That's 3. So that's a 3. So the square root of 1/9 is 1/3. And if you don't believe me, so we're trying to find a rational number that you multiply twice. That would give you that 1/9. I did it individually, but you can think of it like this: 1/3 times 1/3. 1 times 1 gives you 1. 3 times 3 gives you 9. This is just a note. That's why we got 1/3. So 1/3 would be the square root of 1/9. Or you can think of it as parts. Square root of 1, 1. Square root of 9, 3. It's easier like that. And then you have that exponent outside. And that's where you use the power rule of exponents. So you're going to distribute that exponent to that 1 into that 3, or you can think of it as multiplying the base 3 times, whatever makes sense for you. So you can think of it like this: 1 to the third, 3 to the third. So 1 to the third is just 1, 3 to the third would be 27. And that would be the answer. Or the other way, let me do the note here. The other way to think is you're multiplying the base 3 times, so you have 1/3 times 1/3 times 1/3. So 1 times 1 times 1 gives you 1. 3 times 3, 9 times 3, 27. So that's another way to think about it. That's the answer. Okay, E. So E, this whole thing is part of the thing that goes inside the radical. So let's write the radical. So I'm going to put this whole, the whole thing 4x minus 1 inside the base of this thing, and then that number is the index, the one here, and then you do parentheses. You're going to do parentheses, but in this case, when these things are like this, I noticed on the book, they put it inside because this is a binomial. They put it inside, and you can do that. That you can put it outside or inside. It doesn't really help us because you can't find the fifth root of this, because that would need to be a 5 in order for us to be able to do that. So that's the answer for E. That's it. You can't do nothing with it. Let's say you gave me this just in case, because some of you would say, well, how come you're saying the other thing? Let's say you have this, and then you put the 3 outside. I mean, that's not wrong. This is right, but since we can't really simplify the thing inside, right? Like that, we can't find the fifth root of this thing. When you ever see this, make sure you put the exponent inside with the radical. It looks cleaner. It's more like it makes sense mathematically. This for this answer, but that's not incorrect. It just makes sense. It makes sense for you to write the answer like this for this type when you see that. The other ones, if you notice, they were just numbers inside, so that's why we left the exponent outside, because it was easier for us to simplify the radical like this first and then do the exponent at the end. You could have put it here, but that would have complicated things for you. So just that's when you have to be like mathematically smart or to put things. Okay, so I think I mentioned this one. When you have raised to a negative rational exponent, you would bring it down. This is the rule of negative exponents. So let me do example 3. So write each expression with positive exponents and then simplify. So they don't want the negative exponents. So the first thing you need to do here, for example 3, is to bring down using that rule that I just showed you. To bring down, so I'm gonna bring this whole thing down to the bottom. So you're gonna bring it down. I'm gonna write the note here. Bring the whole thing down. And I think, let me see if they want you to write it in. Yes. So let's bring it down first, so that way you see what happened. So 16, 3 to the 4th power. So I brought this down and I got rid of that negative. Now this is the part where you convert things to a radical form to make it easy on you. So you still have the 1 over, and then write the radical form. Remember, the base goes inside, and put the 16, and then that number below the rational exponent, it's the index, so that 4 is put it like that, And then that exponent, since we're dealing with numbers, it's easier to work with this first, and then that exponent. So I'm gonna put it outside like that. So bring it down here. So you still have the 1 on top over the 4 root of 16. So a number that you multiply 4 times that will give you 16, we know is 2. And you still have that 3 outside. So it would be 1 over 2 to the third power is 8. So 1/8 is the answer for this one. And then I think I'm going to stop at 4. I'm going to try to do another video because this is getting too long. So let's do that negative exponent. So again, we're going to bring everything down first. So 1 over, that negative doesn't change. That negative is still there. That one doesn't go away. The only negative that goes away is the one with the exponent. So 2/3. So we got rid of that. Now let's put it in radical form to help us. So radical form, that 3 is the number that goes outside, the index, the root, and then this number is the radicand, and then you have that outside. So what's the cube root of negative 27? So we still have that 1 on top. Cube root of negative 27, number that you multiply 3 times, that will give you negative 27. We know that's negative 3. We just did it in the previous examples, and we still have that 2. So 1 over negative 3 squared, you know that's going to give you a 9, positive 9. So 1/9 would be the answer for that one. Let's see if I have time for these things. I think I'm going to stop there for this video. Thank you guys.